All right. 235. Very exciting. They did not let you down. This is the best thing you're going to see tomorrow. Right around 3:30, you're going to see end, but hopefully it'll say end of section 2. And that's where we're headed next. After I show you the solution for this one, you need to proceed to section 2. So in a matter of minutes, I'll be posting, after you watch this video, I'll be posting my solution guide for the 6 questions from the 2015 Real Deal exam. Please be sure to watch each of those videos if any section is confusing. Now let's dig into this question. It is a doozy. They are not letting you down with a grand finale. This is a fireworks of a question. Now it says the probability of winning a game is 0.05. Okay, I got it. And I'm kind of assuming the probability of not winning, or also thought of as losing, is 0.05. Now it also says if I play the game over and over, which oftentimes we do, if I get at least 70% of the games I play in a series of games won, then I get an extra prize. So that means if I play over and over. Now they give me some choices here. So I'm going to play the game 10 times over and over. Then I'm going to play the game 20 times over and over. And then I'm going to play the game 100 times over and over. Which value for n should you choose in order to maximize your winning potential to get that prize? And so we know the probability of winning no matter what is half of the time. But every once in a while, if we play over and over and over again, maybe I would win 70% of the time. And this is a great question to illustrate why repeating things in a casino is not going to help the guy who's trying to win a prize. And so that's how the casinos make money. So I already, kind of knowing that, think that it's in 10, but I want to calculate this. So first off, I notice this is bin. So if this is a free response question, you're going to write that out, and you're going to write out the words, I know it's binary or binomial because there's 2 outcomes. And S stands for success, and these are pretty much SUs. This stands for success, and this also illustrates that. The probability of success and the probability of not winning, success and not success, add up to 1. And there's only 2 possible outcomes, and you know the probability of that happening. Then independent, and so we should assume that each of the games are independent, and N means the number of times you're going to play the game is set. If it's not set, then it's bits, and that's called a geometric distribution. So we know this is a binomial distribution because it's binary, 2 outcomes. So we're good to go. So that should make you think, and we haven't done a question like this in a while, but that should make you think that it is definitely a probability question, and it's a distribution. And so a lot of people forget about these buttons. We haven't been down here in a while. There it is, binomial distribution, geometric distribution. And PDF is if I know exact value. CDF is if I'm looking for bounds. Okay, so let's go ahead and do that. So I know that this is a binomial, not a geometric, CDF, because I want to win. So let's go ahead and select that on our calculator. Binomial CDF. Notice I need to know the number of trials, the probability of success, the lower bound, and the upper bound. So what I'm trying to do is calculate the probability of winning at least 70% of the games. So when N is 10, 70% of 10 is 7. So I want to win at least 7. So that would mean number of trials, probability of success, lower bound, upper bound. These are the numbers I have to type in. N is 10. The probability of success is still just 0.5. My lower bound is 70 or 70% of the games won or greater, I win a prize. So that would be I win 7 games, 8 games, 9 games, or 10 games. Now we know it would be crazy rare to win 10 games in a row. In fact, they'd think it was a rigged game. But we're doing the probability, and so the lower bound would be winning 7 out of the 10, and our upper bound would go all the way up to 10. Now, plugging that into the calculator, that part's pretty easy. So if I did 10 trials, I still have I win half my games. My lower bound is 7, and my upper bound is 10. I hit enter, and it went away. So I'm just gonna type it in again. That happens sometimes. You just try again. If you don't succeed. So I'm gonna try it again. Not sure what happened there. Binomial CDF. We had 10 trials. The probability of success is 0.5. My lower bound is 7. My upper bound is 10. Here we go. So the probability of me winning, notice that is a pretty low. So it's only 17% of the time. If I only played 10 games, would I win 7 in a row or more? Or excuse me, they don't have to be in a row. Any 7. And so there's a lot of math that goes on behind the scene that the calculator is doing because it's any combination of 7 out of 10 games, all the way up to 10 games. Now let's calculate it if we change the in. So I go to binomial CDF, and I want to change this. And now they want me to try out in 20. So what if I played 20 games? And so I kind of have to do this again. In is 20. And so what is 70% of 20? That would be, they want me to win at least 14 games. So I'd need to win 14 or 15 or 16 or 17, all the way up. I could win 20 games. Super rare, but there is a minute chance of that happening. So I'm going to do this again. I can go stat or probability. It doesn't matter, but I want to get to distribution. I'm going to scroll down. I get to binomial CDF because I have a range of numbers. And here we go again. Number of trials, 20. Probability of success. Lower bound we now set is 14. That's 70% of the games or more, winning 100% of the games. Now we get a lower. So that's what happens in gambling. The more you play, the chances of winning in a row or the chances of winning 70% of the time goes way down. So I pretty much know my answer, but I'm going to go ahead and just keep on cooking. Binomial CDF one more time. What if I played 100 games and the probability of winning is still 5? 70% of 100 is 70. And so what would be the chance of winning 70 or more games if I played 100 games? Let's go ahead one more time just to make sure we know what we're doing here. Probability, distributions, scroll on down to binomial CDF. I'm doing 100 trials now. My probability of success is 0.5. My lower bound is 70. My upper bound is 100. I hit enter. Oh my, look how rare that is. And that's what happens. Nobody beats the casino unless they're cheating. You play lots and lots and lots of games, you're not going to win 70% of the time if the probability of winning is 50%. So, there you go. Definitely the value that would maximize my chance of winning this prize is n equal to 10 only. Yay! Good luck on the test tomorrow. Go to those free response question videos. Bye.